Welcome to the Titus Timeout Podcast. I'm Jenny Abney-Civy, and today we're going to discuss fan curves. The fan curve shows the operating range of a fan-powered thermal unit. Other HVAC equipment, such as supply and exhaust fans and air handlers, have fan curves as well, and they're basically the same as thermal unit fan curves, but I'm going to specifically discuss fan curves as they relate to fan boxes. Fans are pressure dependent. This means that their performance depends on what pressures they operate against, called the downstream static pressure. In other words, the airflow, the CFM, is dependent on the static pressure that they're working against. In general, the higher the pressure, the lower the CFM. So now let's draw a fan curve. For fan boxes, the horizontal axis of the fan curve shows pressure, and the vertical axis is CFM. Other products you may see the axis switched. Let me add some pressures and airflows. The fan curve will show a maximum and minimum airflow range for that size unit. It'll look something like this. The top line is the maximum line, the bottom line is the minimum line. Let's look at the maximum line. So if you look at a point up here, at 0.2 inches of pressure, you have just under 800 CFM. We'll call it 790. But at 0.6 inches of pressure, you have closer to 600 CFM. So you can see when the pressure increases, the airflow from the fan box decreases. Same thing for the minimum line. Down here at 0.2, you have about 250 CFM, and at 0.6 inches, you have about 175. So where do the maximum and minimum fan box curves come from? The maximum fan curve is basically the fan operation at full voltage. Before we talk about the minimum fan curve line, let's talk about the most common way to reduce the airflow of a fan box. Let's scoot this out of the way. The most common way is to use an SCR, which stands for Silicon Controlled Rectifier. I won't go into the details of the SCR. You can look that up online or maybe on Wiki. But basically, the SCR is a voltage chopper. By turning down the SCR in a fan box, you send a lower voltage to the motor, which slows it down and lowers the CFM of the fan box. So say at 100% here, you're at full voltage, but as you rotate the SCR down, which is usually done just with a screwdriver, your voltage goes down to some minimum. But motors can't be turned all the way down. The standard motor for a fan box is a PSC motor. PSC stands for permanent split capacitor. Again, I'm not going to cover the motors in this podcast, but you can find more online. PSC motors used in fan boxes have an RPM range, revolutions per minute range, that they have to operate within. And the PSC motor used in most fan boxes goes from 600 RPM up to 1050 RPM. So as you turn the SCR down, you need to stay above the minimum RPM for the motor as well. The way fan box manufacturers do this is by setting a minimum turn down on the SCR. This is based on the manufacturer's fan box testing to ensure that over normal operation pressures, the SCR keeps within its operating range. So back to the minimum fan curve line. The minimum fan curve represents the airflow when the SCR is at minimum, or the line where you stay above 600 RPM. Now in real life, fan boxes don't operate just on the minimum or maximum fan curves. So how do you use the fan curve for fan box selection? Let's draw a fan curve real quick. What you usually know when selecting a fan box is what pressure it'll operate against and how much airflow you need. So any point within the two fan curves is an acceptable selection for the unit. You don't want to select too close to the maximum fan curve though, because if your pressure increases, you won't be able to get the airflow that you need out of the unit. For instance, if you select the unit at 0.2 inches of pressure and need 700 CFM, you're fine right here, but if for some reason your pressure increases to 0.3 or 0.4 inches of pressure, you won't be able to get as much airflow out. Now you may be around 650 CFM and not have enough for the space. Ideally, you'd want to operate in the top half or top 2/3 of the fan curve. Selecting towards the bottom is okay, and it allows room for increasing your CFM later, but as you turn down the SCR, the boxes will become less efficient. So that's how you use a fan curve. Thanks for taking the time out with us.